Hey, hi. Myself Akshay Kurhekar, a blockchain developer and content creator. So, in today's podcast, we have a very detailed conversation with the Nikhil, who is the CEO and co-founder at Predicates. So, we have understood here what is Predicate, how it's work, how it's operate, what's their contribution in the blockchain ecosystem, how they are writing the policies on top of the transactions, or how they are helping businesses to simplify their processes and their policy management. And we have deep dive into the fintech world of how blockchain is important with respect to fintech. What's the view of Nikhil on that front? How CBDC works? What's their view on the CBDC part? And more on the blockchain side with respect to EVM and public chain. If you are working or if you are interested to learn blockchain, do watch this video. It's very helpful and very informative one. So if you find this video helpful, please like, share, subscribe, and share this video with your community. Thank you so much. And don't forget to comment your view in the comment section. See you in the video. So, hey, hi Nikhil, how are you?
Good. How are you, Akshay?
Yeah, I'm good. I'm good. So, very first, welcome on our YouTube channel. So, this is gonna be a very great podcast. So, hi guys. Let me give you a quick intro of Nikhil. Nikhil is a co-founder and CEO of Predicates, which is an amazing product-based company. Now we got to know more about Predicates from Nikhil himself. So, hey, hi Nikhil. Over to you. Let's start with the small intro of yours and then about the Predicates. Yeah.
Yeah, sure. So, Nikhil, co-founder and CEO of Predicate. I am based in the United States. Before starting Predicate, I was head of strategy and innovation at the Celo Foundation. Essentially, led most of the major Web3 deployments on the Celo blockchain. I've also been very active in the digital asset policy space as a senior fellow at the Atlantic Council, which is a Washington D.C. based think tank. And yeah, I've spent a lot of time in crypto. I've been in crypto since 2018. So that's
Nice.
kind of what really when I made my entrance. And then before that, I've spent time in economic consulting in the litigation space and management consulting, focusing on public sector, private equity, and pricing strategy. Not as exciting as crypto, obviously.
Yeah, more compliance data is like some documenting stuff. More like yeah, it's a good one, but it's a pretty important one.
Yeah.
True. So
So,
hmm,
or yeah, go ahead.
yeah, good. What about the predicates? How you started the
Yeah,
journey?
I was
Predicate.
going to talk about what Predicate is. So, what Predicate is it's a protocol that is enabling any application project ecosystem set their custom pre-transaction logic for how transactions are processed and expressed. And so, there's a lot of different reasons for why you might have some type of pre-transaction logic for what goes through your system, and that could be for your smart contract, your solver network, your sequencer, really anything on chain. And that's what Predicate is designed for is pre-transaction logic for anything on chain. And we call them transaction prerequisites. And so
Transaction
different use
period.
cases for this can be, to make this more tangible, is this could be for something like anti-money laundering. How do you prevent high-risk assets from going through your smart contract stack? This could be used for stablecoin minting requirements. So you're saying we want to mint stablecoins. Is there sufficient collateral to be able to mint a stablecoin? Do you want to be able to mint any amount at any given point in time, or do you want to actually set a limit for how much can be minted? This could also be used for anomaly detection. So how do you prevent an exploit from happening before a malicious transaction goes through? And then another example I can give as a takeaway is intent-based systems. So how do you set parameters for your transactions your outbound transactions? So I'm going to express an intent and say I want XYZ, but you might actually have constraints or requirements for how you want that transaction to be expressed and executed on chain. And so how do you actually do that? You use something like Predicate to do it. So we plug into intent protocols as well. So I'll pause there. I know there's a lot of different pieces.
Okay, amazing. That sounds something crazy, but I'll come to the more deeper questions for that. But before that, as you are a CEO and how you reach this word called predicates, why just predicate? Why not something else? What does
Yeah,
it
this is
mean for you, the predicates for you? Yeah.
So we've renamed a few times. When we first went in, did our fundraise in 2023, we have our labs name, and then initially we were actually called Aethos, and then we shifted to Predicate. No
Oh.
change in our underlying technology stack. It was just the
Uh-huh.
evolution of our name, and it's really because the name Predicate, and this is we're not going to change it anymore. This is it. The reason why predicate is
Uh-huh.
our system essentially enables what we call predicate functions. Predicate functions are in the world of just the definition of predicate. Predicates are basically some type of thing that's done beforehand, right? So let me pull up the definition of predicates here. I can just go ahead and read it out.
Yeah.
It's found or based something on, right? That's the definition. And then there's of course the like grammatical one, which is the part of a sentence or clause containing a verb and stating something about the subject, right? So you can
Correct.
take it either way. It's either you're basing it on something or it's about the subject. And that's really what we're doing here, right? Because we're saying that a transaction is going into something. So what should that transaction be based upon, right? What is kind of the precondition of that transaction? And so that's why we use the name predicate.
Okay. Amazing. That's something amazing, man. Good one. So now let's come to the what exactly predicates doing. Now I have one more question. Let's say you said uh, we have to do something before happening the transaction that will be executed through predicates. But what if, because what I can collect from the smart contract point of itself, smart contract gets built for some
Yes.
for some transition, for some rules and some for policies itself. The commit like that, you can programmatically do whatever you want to do, and based on those conditions some transactions will happen or some transfer of coins will happen. So how it is different, like what exactly predicate is doing, which can smart contract cannot be do, or smart contract don't have capability to do such things. Yeah.
This is a great question because you're saying, wait, so why do we even need this in the first place for smart contracts? I thought the whole point of smart contracts is this type of programmability, right? Like, why do we need?
Exactly. Yeah.
So this comes down to really what a smart contract has capability and programmability and what it doesn't. So you're right. Within any given transaction, within any given block, a smart contract has a programmability of saying, hey, if certain things happen, then execute, right?
Right.
Now, what a smart contract can't do is a smart contract can't natively pull historical information, can't natively do a compute, can't natively pull information from off chain to be able to do that. And so that's one of the challenges here for a smart contract is a smart contract doesn't have the computational capability to be able to do anything that's more comprehensive when it involves a pre-transaction logic. And that's really where we have to start thinking about, right? So you want, let's say an example is the stablecoin minting requirement. For a stablecoin minting requirement, of course you can the smart contract can say, oh yeah, like if the person submits, then mint. But what it can't do is it can't tell you how much collateral, how much has been minted already. It can't tell you how much collateral is off chain. Those kinds of
Hmm.
requirements are things that you can't do within a smart contract itself. You need the additional input necessary to do that, and you need the computation to do that. There's good lessons here from things like coprocessors, as well as
Hmm.
Oracle networks, right? And then same with intent
Right.
systems is you need to be able to figure out like what has historically happened, and if you're going to send a transaction outbound, what are all the conditions you need to have for all the different pathways that a solver does, right? And so
Right.
in that case, a smart contract itself can't do that. You require the additional computation, and that's where Predicate comes in, is providing that additional computation.
Okay, that's great. So what I understood from the explanation you have provided, it's like, of course, smart contract has the capability to do transaction, but something which cannot collect the previous data, or data which is not on chain at that particular time, or which is already event which is already occurred, and now at that instance smart contract cannot fetch that particular event. In
That's
such
right.
situations, we can use predicates to do some computation on some events which is not on the chain. The data which is not on the chain, we can pull it from off chain or some or db or sort of things, and it can hold some business logic as well at the same time to do some
That's
sort
right.
of task, right?
Yeah, it's
Okay.
generally speaking,
Hmm.
predicate is designed for before the business logic, but it's
Hmm.
you're if you're referencing any type of historical on-chain information, information from another chain or off-chain
Hmm.
information,
Hmm.
you'll have to use something like predicate to do that because your smart contract itself can't do that type of work.
Okay, but I have now one more curious question. What if most of the smart contracts we use, let's say I'm building one app, and in my app I'm using the Node.js technology to pull the smart contract and do all those things. So why cannot I do certain things programmatically in my Node.js if I have some off-chain data there? So before executing some smart contract, if I want to write some prerequisites, I can do that computation on my application layer. Oh.
I mean, so if you're going to pull off-chain information through like your Node.js, you're basically
Mm.
running you're doing an oracle, right? Like
Yeah.
you can do the same thing with price data and say, I don't want to use a chain link, or I don't want to use a pit. I'm just going to build my own oracle system. You absolutely could. You can, for specific things like that, you could. Now, my question here for you is, are you going to go and do it every single time for all the different inputs that you want? Are you going to go and do that? And then you're going to have to basically spend the time building that logic yourself. It's the same thing as like, is everyone going to build their own oracle system as an example, or their own interop system? If you're going to say, oh, I want to make a cross-chain call, you of course could, but you're now also imposing potential risks to your entire system, right? Because you're adding additional logic that isn't part of your core work. And the question then is like, how are you maintaining the security of your information that you're pulling in? So that's where this starts coming in, is you absolutely could. You can always pull off chain data. Now, my question would be, what's your latency? How responsive is it? How much time are you spending to build it? Do you have to maintain it? All of those things. Whereas we would say, like, it doesn't make sense. You have the whole point of blockchain is the fact that you have building blocks and open source tools that you can just go ahead and leverage for different pieces. And so we were like, developers are already having to do this exactly like how you said it. You're like, why would you do that? And why would every single developer do that for different use cases? We can build a universal mechanism.
Okay. So now I have another question. Let's say you have mentioned about the few terms about the latency, security, and execution, where exactly we are executing our pre-transition logic. So in predicates, do we have a separate chain for that, or at which layer exactly it executed?
Yeah. So we are not our own chain. We use off-chain, a network of operators. So a form of
Mhm.
off-chain compute. We have a distributed network of operators of, I believe right now, like it's a permission set, but it's 50 plus operators right now. Think of like all of your reputable organizations such as Figment, Hashkey, Chorus One,
Mhm.
Nethermind, all of these groups. So they run operators, and their system is they issue signatures on chain. And so what you do is if you're an application integrating Predicate, you're essentially saying that the transaction can only go through if it is submitted with a signature from the predicate operator network. So we're not our own chain. So let's give an example flow here. Let's say you're a privacy protocol, right? Uh,
Mhm.
and you're worried that you're going to have a sanctioned entity like a North Korean like entity looking to use the privacy protocol to launder their funds. So this is where you use predicate. So you have your deposit contract, or maybe it's a bridge contract because you're a privacy chain. So what you have here is if a user is about to submit this transaction and you've integrated predicate, the user in this case, if they're interacting with an interface, the interface first makes a call to the predicate operator network. The operator network says, hey, okay, we're going to take a look at this transaction, and you've set a policy for preventing money laundering. You don't want a bad actor to go through. So the predicate operator network will reference an off-chain data source such as a TRM or an Elliptic or a Crystal. These are all blockchain analytics companies that do a lot of work on identifying high-risk activity. So they'll go and make that reference and say, hey, does this transaction look high risk or not? They'll get a response saying, oh no, this transaction looks good. So the operators will say, okay, great, this looks good. We're going to issue signatures. So they'll issue a signature. So then when the user submits the transaction includes a signature from the predicate operator network. Transaction that
Okay.
only goes through into the privacy protocol because it has a signature from the predicate operator network. So you basically, in this case, built a deposit screener for your privacy protocol through predicate.
Hmm.
That's the flow.
Amazing. So yeah, so you have a chain of operator, and as you mentioned, it's a permission one. So only the people or the entity which has the contract with predicates, they can operate that operator and build the policy layer on top of that operator. And based on the signature, it gets verified. Is it the valid operator or not? Yeah,
That's
that's
right. It
interesting.
has to be an
Yeah.
approved operator in our network. And we use eigenlayer as part of this as well. So we are an eigenlayer ABS. We leverage a network
Mhm.
of operators that also work with eigenlayer.
Amazing. So I hope it's So which chains does this support? So is it EVM or Solana or any chain? Doesn't matter which anywhere.
Any chain. Right now, we've just done it on Ethereum because of
Hmm.
that was our initial use cases. But for example, we'll be launching on other chains as well, and we support other chains as well. So for us, it's quite easy to launch on new chains because all we really
Hmm.
need to do is we have to issue a verifier contract on
Okay.
a smart contract on every other chain. Because what happens is when I talked about the flow, at the end of the day, the signature goes through, right, and the transaction is submitted. The
Hmm.
final step of this is verifying that the signature
Very
came from our operator network and not someone, and someone isn't trying to spoof that. And so, really,
correct.
in that case, you just need a smart contract on chain that says, "Hey, wait, here is a registry of operators. This signature comes from
Hmm.
an approved operator." So, in that case, you need to be able to launch that on different chains. Right now, our use cases are just focused on Ethereum, so it's there.
Hmm.
But we've been in touch with many. We are working with many L2s as well, and then
Hmm.
some like non EVM chains as well, such as Near.
Okay, amazing. So still you need a proper. So when you are planning to launch your own chain, any timeline or any, do you have any thoughts on that?
the this like a lot of projects end up launching a chain for one reason or another. Our view
Hmm.
has always been, if we want to launch a chain, there has to be a deep reason for why we want to launch
Right.
a chain, right? And so for us, if we want to launch a chain, you're basically, right now, it's because you're adding some type of state, right? Like that's really what you do. A chain offers you state as storage,
Okay.
right? That's
Right.
fundamentally the value proposition here. And that's because, when we think of traditional
Hmm.
payments as an example, or, NFTs, whatever that is, you're
Hmm.
actually a blockchain is a ledger. And so what is a
Ledger.
value proposition? It's a censorship resistant ledger. So for us, do we need the state or not? We're not actually
Hmm.
making a payment here. We're simply doing a check. So there's
So
no
you're just doing
technical
a
reason for us at
verification.
the moment. Yeah,
Hmm.
there's no technical reason for us to do a
Hmm.
chain unless it's more for a narrative aspect from a technical standpoint. It's not quite there.
Okay.
Um, we can also use, things like IPFS for storage if we want
Yeah.
storage, rather than having to say, oh, we need to do a chain. A chain adds additional latency as well. And what we care about is we care about a high performance system that has sub-second latency, really sub 500 millisecond latency, and a high throughput, right? So we
Hmm.
want to be able to, our goal will be to meet the throughput of really the global financial system. So if you look at Visa, that's 65,000 TPS. Like that's where we have to get to. A chain starts limiting those kinds of features. So there's no reason to launch a chain at the moment. Now, over time, if like, oh, there's a reason to, then we can.
Uh,
But otherwise, a chain starts adding additional complexity when it comes to latency and throughput. And so the question then is like, wait, so why do we want to affect the user experience or the developer experience? It creates a substandard product.
True, makes sense. If you are launching chain, there should be a damn pretty great reason to do that, and people should start using that chain and start scaling that, just contributing the scaling as to act as a validator or miner or whatever else concept you are acting as. So already you have a chain, sort of thing, but that's a permission sort of thing you are already doing in somehow, but not in a public way. So it's like a permissioned chain sort of thing, right? So only
Yeah, it's a
few
lot.
are.
I think the best
Yeah.
the best example of the permission structure here is like Wormhole's Guardian Network, right? So there's good lessons here. I would take
Mhm.
Wormhole, Layer Zero, and Chainlink. That's like where we've drawn a lot of inspiration from, and Redstone
Okay.
as well.
Uh-huh.
Wormhole, of course, has a permissioned operator network for cross-chain messaging and interop. It's 19 validators in their system. And
Hmm.
there's a reason for why they did that. They said we can get high throughput. It's highly effective and
Yeah.
efficient to do that. So Wormhole did that. So
Hmm.
we looked a lot at something like that. So we said, wait, we can move much faster if we have a permission network. That being
Hmm.
said, look, we're always open to adding new operators. So it's not like we haven't made it as tightly wound as Wormhole. If a new operator comes in, it's like, hey, we want to participate, we can add them. We just don't have slashing conditions at the moment because we permissioned
Hmm.
it. In the future, what this becomes is much more permissionless. So it won't be permissioned
Hmm.
in perpetuity. You eventually will have an open network that anyone can run an operator. And in that case,
Oh.
you'll have slashing conditions. But in this case, now we can start looking at something like a layer zero, where a layer
Hmm.
zero has anyone can run, they call it a DVN, anyone can run a DVN on layer zero. But you can
Hmm.
also select a subset of specific DVNs you want to use. So for layer zero's interop, the standard is layer zero labs's DVN
Hmm.
and Google Clouds. but then you can also use others. In the case for Predicate, what we will have is the ability for you to use a full quorum of global operators, or you can select a subset of them, or you can select specific operators that you want to work with. Maybe you're a financial institution, and you'll say, look, we don't believe in this whole like permissionless operator network and like any type of economic security. This looks really shady for us. We want to run it. We want to have a specific operator. We're going to run it, and then we'll have another one, which will be, let's say, a Figment, right? Because we already work with Figment on institutional staking. That's it. So you have that type of flexibility and modularity. So that's kind of the layer 0. And then, of course, from a Chainlink standpoint, Chainlink was never a chain, but they have this entire validator network for attesting to for oracles. And so again, it's kind of that type of inspiration.
Right. I think always this is a good decision to build our system in such a way it could serve for some identity which want a closed environment, as well as an identity which needs public information which is open for public usage. Like, that completely makes sense. But now I want to understand one thing. We are talking about here operators, but what exactly operators? If you want to give a generic definition of operator in your use case exactly.
Yeah. So an operator here is simply it's an organization that's running a machine. On our website, it actually gives the technical requirements to run an operator on Predicate. And what they're doing is they are issuing signatures. That is their job. So an application or a developer sets their specific prerequisite, their policy for what transactions they want going in. Now you need someone to enforce that policy, right? You need someone to say, oh, yes, this policy has been met. This requirement has been met. There's a few ways to do this. One is that you use our system and you trust us as a sole responsible party for that. And you're like, hey, Nikhil, you guys are going to check every single transaction. I would wager that's not the best way to do it, because then, I don't know, maybe I'm a trustworthy person, maybe I'm not, but you're putting a lot of trust in just me to say, oh, every transaction here is good. Because if I suddenly disappear, now every transaction going into the system is blocked, right? Like it can be blocked, or I can say, oh, hey, actually, like I don't really like your policy here. I'm going to put in my own, or I'm going to say I'm going to block everyone else's transaction except for mine, because I want to take advantage of a yield that you just put in here, right? Huge, like there's a huge vulnerability there. So we said we should have a distributed network of operators. Thinking of like a more traditional crypto economic security, like consensus model. And so in that case, what our operators really do is they just simply verify, they reference the policy that's been set, and they issue signatures for every transaction. That's their job. It's ECDSA signatures. We at one point thought about, you could do it in a ZK model as well. Problem with ZK is that it's too slow and it's too expensive. So when we're talking about meeting the needs of the application, we can't be the bottleneck for that. So the user experience cannot change. The user should not know that Predicate is happening in the background. Unless they go and take a look at the code, they should just be like, oh, let me submit my transaction. Okay, great, it's through. If you start putting in something like a ZK, now suddenly the computation overhead goes up. So now the user has to pay more, and the transaction is slower. And so we're like, this doesn't make sense. So that's why we didn't do it. And so in our case, the operators have to be able to issue a signature really quickly. So the first, let's say you set a quorum of 3 operators in our system. It's the first 3 operators that issue a signature. So you're not waiting for everyone. How do you ensure like really, really high speed here?
Okay, amazing. So we have a quorum of operators, and the basic work of operator is to issue the signature. But I hope at the same time, as you mentioned, it will give a capability to verify whatever the things we are issuing, right? Operator, the quorum of operator, or through consensus mechanism, it will verify whatever the transaction is happening through predicates, it's all properly verified or not. Amazing. So now I have one more question with respect to operator itself. Let's say I want to build a dApp using predicates. So in which case I can act as an operator, or in every case, let's say if I want to build let's say medium level dApp with not a lot of policies, but let's say 10 to 15 number of policies. So do I need to be a operator over there, or it's just trust
We don't need to be an operator. We don't envision that most of the dApps integrating Predicate would run their own operator. We think that people who want to run an operator and want to earn rewards for enforcing a policy, they run an operator and they're going to have to run that compute. But we don't envision that most people will run an operator, because you have to run a machine for that.
Right. So in like businesses which require a lot of policies or which are have number of tasks happening before the actual transactions, I think those only will run their own operator sort of thing. Is my understanding correct, or is there different
Again,
logic?
it's up to them on
Hmm.
what their trust assumptions are and whether they want to run it or not, right? So it really
Okay.
just comes down to like how they want to think about it. Like it's the same as like, um, for an Axelar or a layer zero, if you're using them for interop, like are you going to go and run one of their validators as well because you're using them? Most
Okay.
projects won't. Now, maybe some will because they're like, hey, I specifically want to trust myself as part of this quorum. And that would be the reason to do it. But you generally speaking, you don't need to. The whole point of having a distributed operator network is like, I can go and
Hmm.
use a set of operators without me having to do it myself.
Okay. Okay.
Right.
Got
The
it.
whole yeah, and part of this too is that when you're building any type of prerequisite, this is not part of your core business logic. You want to focus on really the core part of your work, which is whatever application you're building. You want to go and get adoption.
Right.
This is not the thing you want to do. And so if that's the
Right.
case, Predicate is meant to make that entire process easier, to simplify
Hmm.
that. So if you're running your own operator, you're obviously adding more work on your end because now you're like, hey, I have a DevOps engineer who needs to run this operator in addition to
Separately.
all the other work we need to do.
Right.
I imagine for most people, they'll say, look, like we don't want to run an operator. Now, a
Right.
financial institution might, right? So if you're thinking about like an institutional Uniswap V4 hook, for example,
Hmm.
um, an institution might say, well, look, we want to run one of the operators. But generally speaking, I think most people will not want to.
Completely makes sense, right? It's up to their business and this strategy how they want to
Yeah.
follow the things. If they are
Yeah,
okay,
we've
yeah,
been in touch with
here
some
we
of the
go.
market makers too, where a market
Hmm.
maker might want to run an operator because they're the ones who are deploying capital on behalf of an application, right? They're getting paid by
Right.
some project to say, hey, market make for my token. And the market
Hmm.
maker, if they're in the US, will say, oh, wait, but we have certain requirements for transaction execution. And so maybe they'll
Hmm.
say, we'll run an operator in this as well because we are part of this flow and this is our work. But the application will say,
Right.
cool, but we're not running an operator here.
Right. Right. So, by any chance, are you aware about the Hyperledger ecosystem? Hyperledger Fabric, they have their own permission nodes or something like that. I'm feeling something similar to sort permission operators you are running based on the demand. If they want, they can run. If they don't want, you don't need to run.
Yeah, that's right. That I am familiar with that one. I think of I still kind of lean more towards like the world of layer zero because
Layers.
of kind of how they're designed and like because Hyperledger it's like within the
Yeah,
specific
it's
hyperledger.
complex stuff. It's they
Right,
had
exactly,
own complete business logic, their channels and organization. It's like a complete set of things. Just I'm trying
exactly.
to understand the chronology at the basic. But I got the point. I got the point.
Yeah, yeah,
Yeah, perfectly. So yeah, I think you have just mentioned it's not at the day one you are thinking to launch your own ledger or layer blockchain, but if sometime later when you launch and if you are planning to launch your own cryptocurrency as well, so please don't forget me to send some tokens in advance. Because
no, for sure.
I gotta know these concept life policy, the governance and proper transition is gonna be a next big important things in I think in this blockchain ecosystem to make it more secure and proper to understand, or we can say to run the proper businesses, right?
Yeah, that's right.
Right.
I think it's
So
because if we believe that we're scaling, if blockchains are going to be the global financial settlement system,
hmm,
that is how global financial settlement systems work, right? Like there are
right.
prerequisites to every transaction. You make a payment from like let's say if you could talk to someone like at like at a bank, let's say like a Goldman Sachs or a
Hmm,
UBS or something. You're like, how does a payment work? We're going to talk about the fact that checks happen across the entire stack. You have all these different systems that route transactions. There is
right.
for this to really work, you have to have these types of prerequisites. And in the same way, if we're thinking about a global financial settlement system that involves interactions between regulated and unregulated
Hmm,
markets, and interactions between different regulated markets with different regulations, these are the things that have to happen for any real larger capital to come on chain. And you need an expressive system rather than something that is constrained to like a specific view
hmm.
or a specific like opinion on how it should be. We're trying to be as unopinionated as possible.
Yeah, amazing. So, as we are talking about the financial systems and the, do you have, what's your thought on the CBDC?
Yeah. Well, it's an interesting time you asked that because the U.S. government just said that they are not going to CBDC.
Right.
For my view was always that I believe that CBDCs actually work really well hand in hand with more permissionless,
Mm,
decentralized finance. And the reason why is because the CBDC is really something that is, we still use cash, right? And so all we're
right.
saying is like we don't need, like we're not envisioning a world in which cash is suddenly removed. Even with stable coins, the idea is that you still have cash for different purposes. And so a CBDC is simply upgrading the the ledger or the banking system of a government. And when we think of like how to make more cheap, efficient payments, things like that, like it matters. And then there's a world of should it be a retail CBDC that's held by us, or is it more of a CBDC that's managed and held by banks? I think of CBDC as more valuable on the bank side,
Banks.
where you get a lot of the efficiencies of settlement, speed of execution, like cross border payments, all those things that banks have to deal with. That's where a CBDC is valuable because you get these programmatic features. But you align that with private, stable coins. That's quite powerful because now you've fully enabled a comprehensive digital payment system in which you have both private money and public money.
Public.
But by removing the CBDC component, you only have private money. But I think that's a disservice when we think about what is a role of like a government in managing money supply and the things that involve like the circulation of money itself. You break that. So yeah, my view is that I think a CBDC goes really well with
Mm.
cryptocurrency. I think it's been politicized, and it's also probably because certain projects have an incentive to say, "Oh, no CBDC," because we will be the CBDC, basically.
That's I think important thought process over here with US government. They don't want to use a tech which is already built by someone else, and which, but what I personally feel, CBD is a very powerful technology and it has a lot of use cases, as you mentioned correctly, in the finance and in the banking settlement things, specifically in the cross border. This is the
Yep.
biggest challenge still at this point of day. We don't have that much efficient technology to do quick settlements, right? And CBDC can play a very crucial or important role over there, but I think you just want to build their own CBDC. So let's wait for that. And I think they're promoting more the stable coins to native to their land. So yeah, it's
Yeah.
pretty decent.
Yeah, there's also this concern that CBDCs can be used by governments for surveillance. Like that has very much come up in the case of like a Chinese CBDC. And
Hmm.
and I'm actually like one of my big reasons of how I got into cryptocurrency was actually because of privacy.
Uh-huh.
Like that was one of my
Okay.
big interests. Um, but what's fascinating there is, yeah, a government can use it for surveillance, but in the same way,
Hmm.
you can have a private company issuing a digital asset that can also be used for surveillance, right? And so
Surveillance, right.
it's just a question of like, so where's the where are the checks and balances sitting here?
Hmm.
In my mind, you can do the same type of surveillance by a private company issuing a stable coin as well.
Correct, correct. It's one on the same thing. Correct. Absolutely, you mentioned it correctly. So yeah, we have a very good time speaking. So I would like to, what's your feedback for new developers or new blockchain enthusiasts who are just jumping into the blockchain world? What will be your feedback for them?
I mean, we definitely need more developers. There's not enough. I think there's, and then I think in terms of like where, in my mind, the most interesting development happens over the next like year or 2 years. Um, I think it's on payments. I think stablecoin payments, anything related to payments, especially because we have to connect all of the digital asset world to traditional, like the rest of the financial system, right? And I think the angle to that is actually through stablecoin payments. That's the one that makes the most sense.
Correct.
You have the other part, which is like the gambling speculative market. That's one, but I think if you're a new developer, I think where you can really say, hey, wait, like let me apply like the principles that I know into like how do I scale this? Like that's where this has to happen. And then the other one I think will be over time will be some of the more intent-based systems and how that becomes more agentic. I think right now there's like this crypto AI component, which is like very hypey, but
Right.
where I think you'll get it over time is how do you abstract? If we really realize on-chain payments, then it starts to question like how do you start abstracting this and making this more intent-based because that's how finance works. So if you're thinking about how finance works, those all go into a world of intents, and that's what I think would be the next thing. But to start, I would say I think payments is really where there's a huge opportunity first.
Yeah, amazing. So payment is the one where we need lot we have a lot of opportunity, of course. And due to payment only we have this much hype of blockchain. There are other use cases are the very small area use case, but still those are very important. Let's say RWA and real world asset tokens. There are a lot of scope in identity sector and a lot of more things. But payment
Yeah,
is
but I think like even the payments part, right? Like the payments part starts fitting into that provides the infrastructure for like the identity component to come in, the RWA
yeah.
component, right? It kind of gives you that common ground for activating all these other pieces.
Right. Ultimately, blockchain is all about the payment. It's all about money, right? But how you are fitting different identity layer, your digital asset layer, or
Yeah.
your supply chain management things, how you are making the by combining all multiple use cases and making a one real, proper, real use case that we need. I think we are missing out with the lot of real world use cases. When we are once developer or innovators will start building real world use cases on top of the blockchain, then it will be a big game changer thing.
Yeah, that's right. Uh, I think you articulated it well. It's that the
Mhm.
great part here is you're able to piece all these different things together, and
Mhm.
so to make it incredibly comprehensive and yeah, like both modular and uh, like yeah, you're able to align all the liquidity together as well. And for that to happen, you have to have like these core use cases that enables all of it to happen together.
Correct, correct, absolutely. So yeah, here we are done with our quick chat. So do we have anything for me before we wind up the call?
Uh, anything for you? What do you mean? Like any other alpha or?
No, it's like
Oh,
no,
me
like
personally.
any general comments or something like that. Yeah.
Yeah, no, this was great. I'm curious. I know you're working on identity, and I think that I'm like curious to like hear like how you work on that because I think there's a lot of interesting angles on identity. Whether it's like you have normal like KYC identity, which I think has been there since like for a few years, but I've also seen a lot of work now on like zk-TLS and how do you bring different systems of identity and have ownership around that. Like that is actually like SSI and having ownership over identity is still a problem that like no one has truly solved at scale, and that is something that
Right.
again also like blockchain is really well suited for that those kinds of things.
Yes. So one of the good identity use case I have seen here in India is like Digi, if you have heard about
Hmm.
it. I don't know. They are using it in a really proper way, but still there are a lot of scopes. Like most of the Indian government tried, state government tried to issue the digital certificates on there, to issue the tickets, railway tickets, using SSM models and so on and so forth, transcript and all those things. But yeah, still we have a lot of use cases over there. So many countries who are trying to do national ID programs on SSI to do the proper ownership like Aadhaar and other things, but
Hmm.
not implemented yet in full fledged. There are a lot of scope. Technology is very new, which require a lot of time to get it mature. But yeah, I'm working in the same sort of thing with, and there are good part is like now the public blockchain has few standard protocol for identities as well, like NFTs. So that's also I'm exploring side by side.
Yeah,
So yeah, I think
no,
it was a pretty,
I'm
yeah, it
excited to
was
see
a,
that actually.
yeah, yeah, sure. So when you are planning to come next time in India, so let's catch up sometime there.
Definitely, I'll be back in India sometime again this year, so I'll be there.
Yeah, yeah. Let's catch up sometime. Then I'll be in Bangalore only. So okay. I forgot to ask out where you stay. You are situated in USA only, or you are
Yeah,
from India?
I'm in the U.S., but I grew up in the U.S. my whole life. I was
Hmm.
born in India in Bangalore, and then
Oh,
moved to U.S. when I was
nice.
very young. I go to India like every year or so to Bangalore actually.
Amazing, amazing. So amazing, Nikhil. Thanks for your time, and it was a very great conversation. And let's catch up sometime in Bangalore. Bye.
Yeah, sounds good. Great talking to you as well. Thanks for doing this.
Yeah. Bye. Bye. Bye.